Hi guys, in this session I just want to showcase my project which is like offline navigation with local LLM. So let's say you are a robot deployed in a national park, so there is no internet or any navigation, so you just lost the route. So in these kind of problem statements, like robots needs to have a coverage even without internet or cloud APIs or Google Map. So this is the problem statement which we want to solve. Like any robotic agent needs to have access to the local maps without any internet. So for that particular problem statement, we came up with this stack like OpenStreetMap and OSRM and local LLM. So it's pretty straightforward. User gives his inputs to this local LLM, which understands the intent of the user, and the LLM gives the whatever the intent from the user, it gives to the OSRM, or OSRM calculates the route and navigation output is ready to the user or the robot or whoever it is using. And yeah, this is the quick flow how it looks like. Take me to nearby checkpoint, avoiding main roads. So it can understand the routing and it can build the input for the routing with whatever the JSON it is requesting for, and the user will have the offline results. So this is what this solves and why this matters. So this particular problem statement solves most of these kind of scenarios, like national park where there is no network coverage, and also disaster zones where there will be no signal at all. Defense, it can go into anywhere without network, so that is somewhat helpful to defense as well. Exploration and also remote robots is the use cases which I can roughly think about, but we have a lot. So yeah, that is the real world problem. AI can't depend on internet, it has to think on its own. So local maps and local routing and local LLM can solve this problem easily. So this is the current architecture which we already have in this repo. So initially we need to extract this PBF files, which are like compressed forms of these files. I mean, compressed form of these maps. So initial one-time pipeline which will extract this PBM file and write all the raw maps into the repo, which are located in under data. Like if you run the pipeline, you'll see data under the data, I mean results under the data. So that is a one-time run pipeline. And next, the inference pipeline is pretty straightforward. You give user intent to this Python file, and it will do its inference with the llama, and also it will communicate with OSRM, and the pipeline, whatever your intent for the output, will be ready for you. So this is the quick architecture which we have in this repo, and we'll go for the demo. So yeah, if you have any questions or ideas, just feel free to comment in the video. I'll try to respond ASAP. When it comes to demo, it is pretty straightforward. You can clone this repo. You create your virtual environment with the requirement file which I've already given. You have couple of Docker Compose files. So for data, it is straightly available in the internet. You can download Texas data if you need Texas, or if you need any other state, go to this link. You'll have the data readily available. Download that to your local repo. In my case, I used data in the same location. I'm overwriting with the uncompressed files as well. So that is the one for running that particular pipeline. Use Docker Compose prep. It will extract things to your local machine. Be aware with your RAM and storage which you have. It will occupy good amount of space though. And the final one, like to make these OSRM and also the maps available for us, just compose up this Docker file. So this will always be running. In my case, they are already running. If you see, yeah, these are the one which are already running. This is the prep file which I used. This is idle because I'm not extracting anything. These two were important for us. Mistral is the local LLM, and OSRM is the routing engine which we have. Cool. Next, model for local LLM to run. Give any model which you which you excite about. In my case, I just use this Mistral 7B quantized model. You can use any model, just keep it over there and do required path changes in this Docker Compose LLM. And that's the in quick flow of setting up things for this local AI, local LLM setup. And the inference flow, so this is the one where magic happens. So I wrote a small Python file where it can do the inference. Like there is one more flaw in this pipeline. Like I need to work or enhance this pipeline to understand the names. Like let's say if I say nearby hospital, it needs to get the coordinates by itself. But for now we don't have that capability yet, so you have to give the coordinates like this, like longitude and latitude via longitude and latitude to longitude and latitude. And the metrics are driving units, anything you can give driving, or you can take the inputs from user also. Like he can say I want to drive from point A to point B via point C. That will also work. If you'd like to give it right, just go ahead. In my hardware is not that support you to do it, so if you have a good hardware, just go ahead and try it out. That's the thing. It takes some time. We can see the logs over here. The local LLM logs looks good. It completed here, and again it is going to routing thing. Looks like it hit. Yeah. So we have the output ready. So this is mostly the verified route, because this is something like I travel daily in these routes, so leg 1 and leg 2 and reach the destination. These looks good to me. I verified with Google Maps. Like they're not 100% accurate. They're like, you can say, 95% accurate. So street names and turn right, turn left, and reach first checkpoint of ours. From that checkpoint, again move in the direction wherever we are heading. So yes, this pipeline is working now. Let me know if you have any questions or any new ideas. Yeah, I'm happy to do that. Thank you.